welcome to the virtual meetup. Today we're going to build a customer Terraform provider in Go together. Before we started, just a little bit introduction about myself. My name is Pingzhou. I am a Senior DevOps Engineer at Palo Alto Build Center in London. This is our website. We are a modern consulting firm helping clients building products. And by the way, we're hiring. So if you are a DevOps engineer, architect, please check us out. And apart from work, I'm interested in cloud automation, big data, and Golang. Before we start here, let's go through some basic concepts about Terraform and Terraform Provider. Terraform is a powerful state machine that makes API requests and marshals resources. And Terraform Provider is a package that Terraform is using to interact with those API. It handles the authentication and transforms the data in a way that Terraform can understand. And there are some we must use Terraform provider at some point. For example, the AWS Terraform provider, the one for GCP, Azure, and yeah. So why not build a custom provider to handle your tags? Just a little bit background information where I got this idea from. I used to be on the project where there is a requirement about mandatory tagging, which is a very good practice. The way we did it is through a Jenkins pipeline, and we write a small GUI function to query those tags from a database on AWS. It works, but it is not so nice. It's not very neat. It's a little bit messy, and it's a little bit overly complicated. And I was thinking about why can't we just write a Terraform provider, because it is querying the data from somewhere, and just keep all the state file in one place, make the interaction clean, and use Terraform to track it. Before you can actually do that, before you can actually build a provider to get those tags, you need an API first, because Terraform provider is the way to handle the interaction between those APIs. And so for this specific demo, I create this little simple API, and I will share with you the GitHub repo later, so you can see the Terraform files here. If you go to AWS further, you'll see, the Terraform files are here. It's a very simple API, just with the API gateway, a Lambda function, and a DynamoDB. So quite simple. And the Lambda function is here, checking the authentication token and get the query string parameters, and querying the data from the DynamoDB. So it's relatively simple. Let's query this API and see what it looks like. So if we query from this path and this query string, those are the information we get from it. And how about this one? Yep, it works. Oh, sorry. How about this one? Cool, it works. So great, we have API. Now we can actually build a provider for that. Demo time. So the plan is I will show you the provider that I already built, and then we walk through the code together very quickly, and then we just build another one from scratch. So you have a better understanding how exactly all the codes come together. Let me show you the one I have already built. So in this demo, I built a customer provider. I call it metadata, and it is getting this. It is configured in a way that we can query the metadata tags from it. So this is a path, this is a query string. It's basically pretty much it's what I want to do with a crow. I query this specific path and the string. I query the specific path and the parameters, and you return the text to me. And that's exactly what I want to do with the Terraform. So how can I build a provider is able to do the equivalent of this into Terraform? Now let's look at the Terraform file. Let's look at the Golang files. Before you can actually do that, there is a main. So ideally, you have some knowledge about Golang. If you don't, it's okay. It's actually not so difficult to pick up. It's just functional based. So and I will write another provider later, and you can see how I copy paste most of the code, which you can do the same pretty much. So this is the main goal, and this is the package we need, the module we need, and this is the metadata. This part is standard. You do it for any providers. So this part is the same. You don't need to change anything. So let's look at the metadata. Now we need a provider file. Here is basically where the provider handles the authentication and registers the resource map and the data source map. So test file here, the data source metadata / tags is here. We register here, and the data source here is doing the trick. The data source tag here is doing the trick. It's doing the actual trick of querying this API and return those data. So here we just define the schema for this provider. What's the input? We need the API token, and the resource map and data source map. And then, most importantly, we need to configure the provider. So this is where this function is doing, is do a provider configuration. And because my API is very simple, the config is basically you need the host URL, which basically is this, which is the base one. You need the host URL and you need the API token. So because my API is very simple, so you can see my provider configuration is relatively simple. However, if you have a much more complicated API, for example, you need to have a temporary, how do you say that? One API you have, anyway, you have a, I cannot think about anyone. I cannot think about anything yet, but if you have a slightly more complicated API where you have specific headers, or you need to log in first and then to return you a token, depends how your API handles the authentication. If your authentication process is slightly more complicated or secure, this part will reflect it. So because my demo is quite simple, the one I'm doing is basically just get the host URL, pass the API token, and that's it. Cool. Now let's look at the data source tag, which is actually doing the trick. The data source tag is here, and here is a data source tag where you specify the schema, the path, the query string, and the tags, which you can see. You have path, you have query string, and the tags is another schema that this data source has, and eventually we will see it when we run it. You'll see it's actually have path, query string, tags, and it's a map of tags we're trying to get. And finally, data source is a rate source, different from the resource of Terraform. The resource one you should be able to create, update, delete, and import. But for the data source, you just need to do a rate. So that's quite simple. This data source tag rate is here. Finally, this is the bit eventually how we handle the API. Like here, we basically call the API. We get the path, we get the query string, we create a new API URL, and we create a HTTP client, set the header, make the HTTP request, and get the data back. And because our tag is a type, the type is a map. So you can see here, we just need to do a tag map and format the data into the right format. So here, the type is schema type map. So you should have a map here. And yeah, and then set the map. The important part is don't forget to set the ID. The ID is actually really important. If it's the resource or data source changed, make sure you change your ID. If the ID remains the same, no matter what the content is, Terraform will assume it's the same either data source or resource. So remember, make sure if anything changes, you should reset the ID. And voila, that's it. That's a data source. And then you output it into Terraform -provider -metadata, and that's important. Make sure it starts with Terraform provider. Otherwise, Terraform won't pick it up as a provider. So let's try it. Let's try to run it. Set it demo. Terraform. And Terraform providers. See, it's pick up the metadata. Fine. So let's pick it up. Fine. So let's try to run it. Terraform apply. Voila, it works. And you can see the output is pass, query string, and tags. That's what we needed. And this information we get is exactly the same we can get from this one. So basically, we are using Terraform provider to do this. Instead of doing a crawl, we just ask Terraform to do it. So if you have some other customized customer API you want to interact with, or you want to integrate it with your existing pipeline or with your existing Terraform file, it is a very neat and easy way to do it. And most importantly, you can track all your changes. So if you made something wrong or different, you want to roll it back, it's easier to do it. It's just a neat and easy way. Cool. So yes, we walk through the code very quickly. The purpose of that is now we can create another one from scratch together. So how about we create one for another pass? For example, we can create one for the releaser. For this one. Okay, let's do it. So if now we want to build a provider, it's called release, and then it will give us the release tags like this. How can we do that? How can we just write the provider to do that? So I'm going to do that now. And it will be a little bit copy paste, and then you can say which bit you need to change when you're making your own provider. So let's do a build mode and add TF demo. Actually, create release. Release and go. Now we just need to copy paste this because it says, oh, sorry. We just need to copy paste this because this is the same for any other provider. This bit is the same. We just need to change this because we won't have metadata. It will be TF release, and we'll have a folder called release. And let's do more tidy. Release. Let's create a folder for release, and let's specify. Tell the Go that it is a local import. Replace. Release. Cool. Release. Okay. Now we just need to go to the release folder. View. Provider.go. Sorry. Provider go. Cool, provider go. You just need to copy paste this. Well, you need to change the package name because here the package instead of call the metadata, we'll call it release. And the API URL is the same, the configuration is the same because it's basically the same API endpoint, and my API is very simple. You just need to pass the URL and the token, and that's it. And we don't need to change this, we don't need to change this. Anything we need to change is the data source map, this data source map, because the provider will be called release. So, well, just make it's the provider will be called release. So you shouldn't call it metadata tags. You'll be called release tags, and we can call it release tags. We can call it release tag. Cool. Okay, we have this, and let me just draw a goal load tidy. Cool. We don't have the arrow anymore because it's able to find the release package, which is what we need. Boom, 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 boom. Go mode tidy, and now we just need to write this function, this release tag, for the to do what we want to do here, to query the API and get those tags. So now if we go to release and we go to view data source release, I will just copy paste it. Data source release tags.go. And the package will be released. Let's copy paste the most of it. We'll change the name later. So the name shouldn't be called a data source tag. It should be called something. It should be called this one. So it's release tag. Put release tag here. And the rate tag, we can call it release tag rate. And release tag rate will be like something like this. Cool. Now we just need to change the schema. So for this one, we don't want to pass any question. We don't want to pass anything. We just create a single release tags data source that returns all the tags, so we don't need to specify the path here. We don't need to specify the query string. We basically just want the tags. And then the path will be hard-coded. And let's see what the path looks like. The path will be v1 tag. And the query string, the query string will be called releaser. And the rest of it should be the same, because if you check how the query looks like, they're pretty identical. They just need to change the last bit. The path is the same. It's just the query string is different. Cool. So now let's go raw main.go. Oh, metadata. Mango. We need to change this into release. Cool. Looks like the battery is built. It looks okay. Now we can build it. Go build. Output. Terraform. Provider. Release. So now the release provider is built. Release is here, release is here. Perfect. Let's test it. Hopefully this works. Terraform init. Nice. So initialize if and initialize Terraform providers. Yes, it can read the provider file, define the release provider. So let's do a Terraform. Apply. Cool. Which is exactly what we want to do, like with the crow. Oh, sorry. Oh. One more. Let me copy paste it from here. See, so here we are basically do exactly the same with Terraform. Does it make sense? I hope it makes sense. I think I might did it a little bit quick, but I want to leave some time so we can actually build this together. So yeah, so it might be a little bit too quick, but I will share the GitHub repo with you later, so you can just spend your time and have a look at again. And also, if you have any questions, feel free to ask me, and I'll leave my emails and my contacts later. So if later you want to build your own and you have any questions, feel free to approach to me. So let's talk about some use cases about this. Use cases about this. The first thing come out of my mind is something like mandatory tagging, naming convention, release management, and also, for example, we can define a list of resources depends on each team. So sometimes the dev person or the development team create a small dev machine, but very big, like a huge instance. We can actually restrain that. Instead of ask one client engineer guessing what kind of DB class or EC2 instance they should provision for a specific team, we can actually make the plan ahead and keep those metadata in a big table or an API. And then those cloud engineers, instead of guessing, they can actually just query it from within this using this data source. So that's one idea I have, something like naming convention, release management, or a way to implement some good practice about how big an instance should be provisioning at the first place. And also it depends on your situation. Like if in your pipeline there are some external or third-party APIs you have been using, and you have been using an external script to interact with this API, you can start thinking about building your own Terraform provider. So you have a simpler, like a cleaner, more neat, a simpler pipeline. So less moving parts, making it more robotic. And yeah, that's what I can think of. Q&A. Yes, questions, please. References. So this GitHub repo is actually available online, and it is public. So you guys should be able to find all the source code here. For example, how the API code and also the Terraform provider source code as well. And also, I have been inspired by some other articles online. The most useful one I have been reading is creating Terraform provider for anything. I was sort of inspired by his article as well. And then more, there is like online tutorial from HashiCorp about how to create your own Terraform provider. And yeah, those are the references. And thank you. Have a good evening.
Thank you, Pingzhou, great demo. Loads of positive feedback in the channel there from Twitch. People saying that it's great to see people thinking out loud and speaking as they go, which is a difficult skill. I am in fact joined right now by Pingzhou over Skype, which is the only video conferencing service that I can connect to OBS quite as cleanly as this. So welcome, Pingzhou. Thanks for your session. No questions thus far from the Twitch chat, so I'm going to start with I guess a couple of my own. So I guess you talked a lot about the use case and the sort of the code itself. Why don't you tell us a little bit about why tagging is an important thing to think about as a whole?
Well, every time when you provision AWS resources, because those kind of auto scaling and because of Terraform, you can actually provision a lot of things together in one go. And sometimes if you don't tag it properly, you probably cannot really know which server is running what. And it will become a big problem if it's actually going production. If you don't know whether or not your middleware is down or your front end application is down, and you don't know which one is the exact one. And so, yeah, I think tagging is quite important. And most if you go through an AWS Web Architect review, one of the best practice is always mandatory tagging. You should follow a certain name convention and tag your resources. And the reason I use Terraform is because the way you tag cloud resources is when you're actually using Terraform to provision it. So if you are using Terraform to provision it, in the same time, you can actually get all the tags. You can do everything in one go. So you get all the tags while you provision your EC2 incidents or any other your cloud resources. The tags is already there. So that's why I think it's actually quite important, and that's why I spent a little bit effort to build this provider.
Sure.
Does it make sense?
Yes, yeah, absolutely. I guess that maybe not everybody needs to be going out writing a Terraform provider, right? Was this solving a specific use case that you couldn't meet using kind of Terraform on its own or any of the other tools?
There are other tools available. So, for example, you can use Terraform external data source. So, for the external data source, you use Terraform to run external script, and within that script, you can get the tags from somewhere, or you can do it through the pipeline. A lot of companies running Terraform through the pipelines. So, as I said, you can use a GUI function to define all the tags, and then do it. It works. Like there's so many other ways to make it work. But the reason I found using Terraform is better is like you don't need to deal with those small moving parts. Think about having Terraform and let Terraform call a bash script or Python script. Doesn't sound very nice when you can actually spend a little bit work with Terraform itself and make it all very neat. And the most important thing is because you build it from scratch, you know exactly what kind of information you have been passing through, and you keep it into a state file. Just easy to track, and if you made a mistake, very easy to roll it back.
Gotcha. And for the people watching who might be sort of thinking, you know, I'd like to have a go at this myself. Obviously, Terraform is implemented in Go, as you've just sort of walked us through. How did you learn Go? And do you have any kind of advice for anybody else who wants to try the language?
Actually, the best way to do it is create a little pet project and learn it from building it. The reason I learned Go is when I was trying to do a little bit. I learned Python for my first one, and then I switched to Go, which is actually not so difficult. And the reason I switched from Python to Go is I found Go is much quicker. And at that time, I was thinking about building a trading bot. It doesn't work very well, so. And I was thinking about where can I find the fastest language to do it, and that's where I started Go. It wasn't so easy, but there are a lot of resources online available, and the community is really big. There is a Go user group, there's a Slack chat group, and they do meet up as well. I found that quite useful. And to be honest, to start with Go, you just need to go through the Go tutorial online. It's only take you about 3 hours to go through it, and you have a good idea about how it looks like. But ideally, you already have some programming knowledge, like Bash script or Python. It's all functional based, so not so difficult.
Gotcha. Just going over to the Twitch chat briefly, Bill Glover shouting out the London Gophers meetup, which is also tonight apparently, competing on our turf, evidently. Incidentally, I checked in on my work Slack earlier to find one of my colleagues pointing out that Bill Glover UK does sound a little bit like Bill G Lover UK, and maybe Azure and Microsoft Cloud is a bit more up Bill G Street. But I think that was a misreading. I'm sure, Bill, you are an AWS fan. There are also Ed's posted some resources for Go in the Twitch chat as well. So please do, if you're on the Twitch chat right now, do feel free to share links to things that are relevant in the Go world. So moving on, I guess, from the sort of Terraform / Go end of the conversation, since we last had a meetup, we have had reInvent, which obviously was not in Vegas, which bit of a mixed blessing. I like being able to go to reInvent, but I don't like Vegas. Vegas is kind of the worst place in America. So instead we got 3 weeks of content, 5 keynotes, and then another sort of 3 days in January where it overflowed into. Was there anything that you saw at reInvent or that was released at reInvent that you were particularly interested in, or that you can see being really useful for the clients you're working with?
Oh, the coolest one I found so far is the new feature for Lambda. You can actually run a container within Lambda.
Right.
So I found that is actually quite cool. The reason for that is so you can see the slide I was using is actually a Go present slide. You need to start a server to do that. Normally, it will be impossible for me to host that in Lambda because Lambda is functional. You have to create a handler, and you have to create a handler, and it's just triggered by function. But now they introduced this new structure that you can actually run container in a Lambda. That is actually quite cool. The next thing I want to try is hosting that demo, which is the Go present. The Go present started a small HTTP server running it. I'm thinking about maybe it's possible to put that in the Lambda function, which is inside a container. That would be very cool. So I found that it's very cool. And another one is the machine learning one. Actually, it seems like they have a lot of new features you have one place to process and train and deploy the data. That's why it's very cool as well.
Yep, lots of good stuff from the machine learning world at reInvent. So much, in fact, that not only did it have its own keynote, but it was in the main keynote as well. I have to confess, I'm not really don't really pay a lot of attention to machine learning stuff, and so it's not an area that I really understand. But hopefully Archie, who's coming up later, will be able to fill in some of those blanks for us. So I don't see any other questions from the Twitch audience other than positive vibes about your talk. So thanks for sharing with us, Pingzhou. We will see you another time. Thank you very much.